When I was a student, it's a long time ago, but we developed landmine sensor. And at our meeting, I realized the need of this nerve agent detection sensor. So I have thought about this for a long time, and very recently we initiate this stimuli responsive material for biosensor application. And then the combination of this development together with some journal reading about this 2PAM, eventually help us to develop this new sensor to detect nerve agent. We basically develop like a pH paper or litmus paper like colorimetric sensor. And the material we use is so-called stimuli sensitive conjugate polymer. And depending on external stimuli, this material changes color basically. And then how we can provide the selectivity or specificity. We read an article and we found that the US Army used so-called 2PAM is an antidote. And this antidote has very specific interaction with nerve agent. That's why when you inject the antidote in the body, this antidote material move and grab the organophosphate, the nerve agent, and then remove from the body. So we just adapt this antidote material into our litmus paper-like material, so that whenever this litmus paper, the nerve gas litmus paper-like material is exposed to nerve agent, it changes color from blue to red. So that without having any big machine, with the view of just bare eye, we can see the color change so that we can detect a nerve agent. So possibly this material can be used for like a security and any like a government building, federal building like that as an indicator. So if the nerve agent is used by a terrorist, this colorimetric sensor, you can maybe put on top of any picture frame or on the wall, and if you see the color change, that means nerve agent there. We show some demonstration in the lab, and student, it's very easy to make. So students use commercially available material. They made small liposome, and then they check the stimuli responsive property, and they like that. They really like that.